Right, okay, so here's a statics problem where we've got a ramp resting on a round cylindrical drum. Okay, so let's look at our extra forces. So we've got a mass of 20 kilos and the ramp is modelled as a uniform rod. So that means that at 4 meters we will have a force of 20 G. Okay, we have got a reaction force here where the ramp is making contact with the ground. We have got a reaction here where the ramp is touching the drum. Okay, and remember basically that we are going to want to resolve this perpendicular to the rod, and that angle is going to be theta. Right, okay, so now let's get started. So first thing I do is take moments. I'm going to take the moments about A, because that's the contact with the ground. So my moments about A, I'm going to go anti-clockwise and clockwise. Okay, so my reaction at C is going to be anti-clockwise, and my weight putting it down is going to be clockwise. Okay, so I've got my reaction N, and that is 5 meters away from the pivot. And on the other side, I've got 4 times 20G times cosine of theta. And this tells me that tan theta is 7 over 24. So I'm going to draw a triangle. And tan is the opposite, which is 7, over the adjacent, which is 24, which means that my hypotenuse is 25. So that means that sine of theta is 7 over 25, and cosine of theta is 24 over 25. Right. Okay, so now I can replace my cosine of theta, and I can work out that N is 150.528. Okay, so that's one of my unknowns found. Now I'm going to work vertically. So what vertical force I've got R, the reaction force. I've got N, but again, I've got to work out the angle. And because it's vertical and perpendicular, again, this is theta. So I've got N cos theta, and that's equal to 20G, which is acting in the other direction, the weight. Okay, so now I know what cosine theta is. I've found N, and I know cosine, so I can just plug all those in, and that tells me that R is equal to 42.14784. Right, last one. I'm going to go horizontally. And we know that as the weight is pulling down, it's pulling my ramp in this direction. So that means that friction must be acting in the opposite direction. So horizontally, I've got friction, and the only other force that's not perpendicular is N. So that means that I've got N, and this time I'm resolving horizontally. So I'm going to use that angle, and what I'm going to do N sine theta, because the angle I've got marked is with the vertical axis and not with the horizontal. So N sine theta. Again, I already know what sine theta is. So F is equal to 42.14784. Right, great. So the question says, B, find the magnitude of the resultant force acting on the ramp at A. Okay, well, the force at A is R, and we found that R was equal to 42.14784. So that's that taken care of. The ramp is still in equilibrium in the position shown, but the ramp is now modelled as being uniform. Oh, sorry, right, the magnitude of the force, right, so I've got R, but the magnitude of the resultant force means basically I've got a vertical force and I've got a horizontal force, and the resultant force is going to be the one in the middle. So R was my vertical, I've got F is my horizontal. So how do I work out my resultant? Well, my resultant is the square root of R squared plus F squared. And when I work that out, I get 66.5 newtons. Okay, literally, because remember when we see magnitude, we always think basically about squaring, taking the thing like the Pythagoras. Okay, right, so now given that the centre of mass is assumed to be close to A and B, because this is not now uniform, so our weight vector would move. Remember we've got our ramp, cylinder, ground, and now let's say our 20G is closer to A than C. How would that do? Well, this would basically make N, the reaction force at C, smaller. And what would it do to A? Well, the reaction force R at A would increase. And that's it.